Next here we learn is equality of matrices. So here we have two matrices A and B as okay, A and B are said to be equal, and what is the first condition for checking the equality of matrices? They are of same order, and the second condition is the element of A is equal to the corresponding element of B. Then only we can say that two matrices are equal. We know this is the general form of representing a matrix. This is matrix A and this is the general form of representing a matrix B. So what here we are learning equality of matrices. Okay, so for example here we have two matrix A 2 1 0 3 and B is 2 1 0 3. See, what is the first rule we have to see? They are of same order. Yes, they are of same order, and the corresponding elements are equal. And these elements, the 0 is equal to 0 and 3 is equal to 3. So we can say that A is equal to B. Fine. Now let us go for one more example. 2 equal to 2, and here the corresponding elements, is it equal? No, it is not equal, right? So these two matrices are not equal. Fine. So here we go for an example. So here we have a matrix of which order it is? This is of order what? 3. Since it is square matrix, we can call it the order 3. What about this? Same, right? So our first condition is satisfied. Now what we'll do is we'll go for, like, since like order is same, so we can compare the corresponding elements, right? So x plus 3 equal to 0, z plus 4 equal to 6, 2y minus 7 equal to 3y minus 2. Why? Because here we are asked to find the value of x, y, z, a, b, c. So you remember you have done in the set, right? If your set is like this, x, and here we have y, and next we have some value equal to suppose it's 1 and the other one is negative 1. So what is the value of x? So value of x is 1. Why? See, when it's equal sets, the corresponding elements are equal. So x equal to y, x equal to 1 and y equal to negative 1. Fine. So same way, okay. So don't get confused how it is taken. It's very simple actually. Okay, same way. So likewise here we need not take, but here we need to. Why? Because for a we need the value, right? So a for minus 3 and 2c plus 2 equal to 0. Then for b again here 2b minus 3 equal to 2b plus 4. See, it's all written over here, and we have found the value of x, that is x plus 3 equal to 0, that is x equal to negative 3, z plus 4 equal to 6, that when this 4 goes this side becomes negative 4, so we get 6 minus 4, that is 2, and here we have 2y minus 7 equal to 3y equal to 2. Fine. So what do we do is, see, usually what do I do so as not to make it negative? I adjust the variable. Okay. So what do I do is, I make here, since I know like 3y is greater, so 2y over here and negative 2 over this side. So 3y minus 2y, it's 1y, that is y, and when negative 2 go this side, we get 2 minus 7. 2 minus 7 is nothing. It's up to you anyhow, you can solve. It's not a difficult task. Okay, to make it convenient, usually I do it. You can opt anyway. Next for a, when negative 1 goes this side, what will happen? Positive 1. So minus 3 plus 1 is negative 2. Next 2c plus 2, this goes negative 2. So 2 by like dividing throughout by 2, what will happen? We get, anyhow, 2 by 2, like when we divide it, we get c equal to negative 1. Next, b minus 3 equal to 2b plus 4. So b this side and negative 4 that side. So what will happen? That is plus 4. When it goes that side, it's negative 4. So 2b minus b is b, and minus 4 minus 3 is, negative 7. So here we complete equality of matrices. Okay, now next we'll be going for the exercise 3.1. Okay, so what all we have learned about definition we have learned in this previous video, then order of metrics, different types of metrics. Okay, so this exercise will be based on that. Okay, and even equality of matrices we have just learned a few minutes back. Okay, in a matrix, here we have a matrix. What is the order? Can anyone say? Usually whenever you see a matrix, just first you check the order, okay? Because obviously based on the order will be proceeding your problems. Is it clear? Okay, see order, how? Row and column. I have told you like what you have to follow. RC, don't forget that RC. If boys are there, they'll be more apt. RC book, like book, car book. When you have a vehicle, like a book is there, you call it RC. Okay, anyway, that is not part of this for the timing, but you should remember this code, that is RC, row, column. So how many rows? And don't forget how you take rows. Horizontal. If you have the tendency to forget or get mixed up, you at least remember how you know the row is always horizontal. Okay, so how many rows? 3 rows, so 3. Okay, by how many columns? 1, 2, 3, 4, right? So what is the order of our matrix? It is 3 by 4. Okay, what is the first question? Order of the matrix. Fine, so we already have the answer. Always when you write the solution, always write the given. Okay, don't forget that. Okay, then when we attempt the first question, sub question, order of the matrix 3 by 4. So here we are done. Number of elements. See, either you count or you multiply this. Which is better? We multiply. Okay, we multiply our order of matrix. So what do we get is 12. To be mature, please multiply. Okay, don't sit and count like small kids. Okay, next what we have, write the elements. A13, A21, A33, A24, A23. So we know this is A11, A12, A13, A14. Likewise, it follows. So what is A13? A13, A11, A12, A13. It's 19. Then A21 is, yes, 35. A33 is -5. Got it? See, this is A33. Okay. Next, A24 is 12 and A23 is 5 by 2. Fine. Okay. Now next we are done with the first problem. Second problem. See, I won't be covering almost all the problems because most of the problems like they will be related to each other. Okay, somewhat similar it will be. So it's not a difficult chapter, so that we should go for each and every problem. So which is a different problem that I'll be explaining. Okay. Now second, if a matrix has 24 elements, how many elements? 24 elements. What are the possible orders it can have? What if it has 13 elements? Solution, as order of the matrix. What is the order of the matrix? How do we go for order of matrix? M by n. So we know that when we multiply the order of matrix, we get the number of elements, right? Mn. So what do we have here is number of elements. How much? 24 elements we have. Okay, so as per the question, we have 24 elements. So possible ordered pairs. What all ordered pairs we can form? Nothing. 24's factors you have to find. That's all. So 1 into 24 and the ulta also. Then 12 into 2, 2 into 12, 3 into 8, 8 into 3, 4 into 6, 6 into 4. Got it? So this is also what you call the orders. That is 1 by 24. If it is 1 by 24, can you tell me the number of row and column? Yeah, this is R. So we have single row and how many columns? 24 columns, right? That is single row will be there and how many columns like this? 24 numbers you will be writing if 24 elements are there. Got it? Okay, same way 24 by 1, that means you have 24 numbers likewise. Rows, right? So 1, 2, 3, and it goes on, and 24 numbers you will be writing, and what in a single column you will be writing. So same way, now I guess you can understand, right? So 12 by 2, 2 by 12, 3 by 8, 8 by 3, 4 by 6, 6 by 4. These are all what? Orders of what? Possible orders for how many? 24 elements. Don't forget, when it is 24 elements, you see the like you form the products, that is factors. From factors you get the products. Okay. Ordered, that is second part of the question I'm going now. Okay. Ordered pairs of natural numbers whose product is 13. As we know, 13 is a prime number, so obviously it will have only two factors, that is 1 and 13. So how many orders? 2 orders, that is 1, 13 and 13, 1, that is 1 by 13 and 13 by 1. Is it clear? So we are done with the second problem. Your third problem is same. Here the number of elements is 18 and the other question is 5 elements. So same, we have to go for it. Now fourth question. See, this question is also important. For 1 mark it may come. This may come for like MCQ type question. For 1 mark usually it comes. Okay, if it comes, maximum 2 marks, not more than that. Okay, construct 2 by 2 matrix where A equal to Aij, whose elements are given by Aij equal to I plus j whole square by 2. Okay, what is the order? It's 2 by 2. I have been telling, please take care of the order, take care of the order of the matrix. Okay, so see, again we have to go for the order, so it is 2 by 2. So what will be the value of I? What it will be? It will be 1 and 2, because I means ith position in the row, right? Okay. So here we have 1, 2 and columns same way 1, 2. So 2 columns, 2 rows. So first what we'll do is, first we'll go for A 1, 1, that is both I and j is 1. Okay, so we substitute in this. So 1 plus 1, we solve it, square 4, 2 square is 4 by 2, we get 2. Then A1, 2, when we solve this, we get 9 by 2. A2, 1, that is I is 2 now, j is 1. When we solve this, here we get 9 by 2. A2, 2. So A2, 2, I is 2, j is 2. So when we add 4, square is 16, 16 by 2 is 8. And at the end, obviously you have to form the matrix. So this is A11, A12, A21 and A22. So here we complete the formation of a matrix A. Okay, next. So somewhat same, so I'm not going for this. Okay, don't forget to form, after solving this, please don't forget to form the matrix. Okay, next question 5, construct 3 by 4 matrix. Okay, in the previous case it was 2 by 2 and here it is 3 by 4 matrix whose elements are given. So here we have a question. What is the question? Aij equal to 1, that is 1 by 2 mod minus 3i plus j. Call it modulus or mod. Fine. Okay, so when we start, can you tell me what will be the values of I? 1, 2, 3. Yes, number of rows is 3, so value of I will vary from 1 to 3. Okay, now what will be j's value? 1, 2, 3, 4. So when we solve A11, half, when you substitute the value of I, j, you get what? Half. Minus 3 plus 1 is negative 2, negative 2, then modulus of negative 2 is 2, so 2 by 2 is 1. A12, when we solve, we get half. A13, when we solve, we get 0. A14 is half. A21 is 5 by 2. A22 is, yes, 2, that is minus 6 plus 4. Yes, minus 6 plus 4, minus 6 plus 2 is minus 4. Minus 4 modulus is 4. 4 by 2 is 2. One thing is sure, like you won't have a negative value because modulus is there. so all the elements will be positive. Okay, so 8 2 3 half, substituting the value of I and j, you get 3 by 2. 8 2 4, when you solve you get 1. 8 3 1, when you solve you get 4. 8 3 2, when you solve you get 7 by 2. These are the simple problems, okay, simple calculation which you have been doing from your lower classes. So I need not go in depth for this. 833 is 3, because you need not spend your brain over here, just a simple calculation it is. So 834, it's, so we come to the last element, that is 5 by 2. So accordingly, please write the elements properly, and when you do these problems, please don't commit any mistake. One silly mistake will lead to loss of mark. Okay, fine. Here we complete this. Okay, so I guess it's almost same, so I'll move. Okay, our sixth problem is based on equality of matrices. So here we have two matrices, so see two equal matrices, so order is same, fine, so we can proceed. So this matrix, so these two matrices are defined. So 4 equal to y, that is y equal to 4. Then 3 equal to z means z equal to 3. X equal to 1. This was the simplest one, right? Okay, I guess I need not go for this also. Let me go for this one. Okay, x plus y, order is same. Okay, so we can proceed. X plus y equal to 6. Then next is 5 plus z is equal to 5. Xy equal to 8. So for finding the value of z is not a difficult task. You'll get it directly, right? So what is the value of z? I didn't proceed for this one. Value of z is, yeah, it is 0. I didn't write it. Okay, I'm sorry. Okay, next. Yeah, okay, we just label it as A, then this is B, and XY is C. So here we'll substitute. What we write is, we write y in terms of x, that is y is equal to 6 minus x. Okay, that is from A we have written, so we mark it, label it as dth equation. So we substitute this y equal to 6 minus x in C. Okay, so that is, instead of y you'll be writing 6 minus x equal to x. So when you solve it, you get 6x minus x into x is x square equal to 8. Now what you do is, so as to avoid x negative, because when x square comes, now it's sure like it's quadratic equation. So what do we do is, just for avoiding a negative, what did I do is, I have put everything this side. So what do I get is x square minus 6x plus 0 plus 8 equal to 0. So when you solve it, quadratic equation, I know all of you know how to solve it. So x minus 4, x minus 2. So what all the value of x can be? So x equal, when x equal to 4, then y's value will be 2. How you got it 2? Because y equal to 6 minus x. So when it is 4, 6 minus 4 is 2, so 2. So if value of x is 2, y will become 4. So here it's done. Next, it's almost same, so I need not struggle for this. I'll move. It's quite easy. So here, okay, still I'll solve this. X plus y plus z equal to 9. Okay, we wrote this 9. X plus z equal to 5, and y plus z is equal to 7. We'll use this two equation and solve it by our old method, elimination method. It's up to you, or do one thing, you substitute y plus z value here, anyhow it is. Okay, so y plus z will be 7, so you'll get the value of x, anyhow we can solve. Okay, so here I've just eliminated z and I got x plus y, then substituted x plus y in this equation, and anyhow you can solve. Okay, so you got z equal to 11, x equal to minus 6, y equal to minus 4. Next we move on to ninth problem. which of the given values of x and y make the following pair of matrices equal. Okay, now here so it's like equal, right? So you have to check the equality of matrices. So here first one, the corresponding element we take 3x plus 7 equal to 0. So 3x okay, so next, that is x equal to, we get the value is it's negative 7 by 3. It's not so difficult to find these things as you have worked out. Okay, so let's see, we'll substitute over here whether it's right or wrong, we'll check. So here if we substitute in this case, that is 2 minus 3x equal to 8. So when it is 2 minus 3 into negative x is negative 7 by 3. So what happened, 3 gets cancelled, minus minus plus. So what did we get? We got 9, right? 9. So do you think it is defined over here? No, right? So it's not defined. So it's not defined, right? But for y it's okay. See, y minus 2 equal to 5. So when you find y will be 7. In this case also same thing, but for x it's not defined. So not possible to find the answer. So here the correct answer is B. Then we move on to 10th question. The number of all possible matrices of order 3 by 3 with each entry 0 or 1. Each entry 0 or 1. So we have 3 by 3 matrices. So each entry can be what? 0 or 1. That is, in each element, either it can be 0 or it can be 1. To find the number of possible matrices, we use a formula 2 to the power number of elements. How many number of elements do we have? 9. That is mn. That is 9. 2 raised to 9. So what is the answer? 2 raised to 9 is, yes, 5, 12. So D, option D is the answer.